implies that 2a minus my c is equal to 0, but I know what a is equal to. That implies c is equal to, is it positive 2? So I now finally have that x of 2 is equal to this mess. That would be an at squared plus a bt plus a c. Check that out. That is my solution for x of 2. And so coming up with a solution for x of 1, let me come back to, I don't know, how about this relationship right here? Inside my dotted black box. You guys, I've got 7 minutes. I think I can finish this. Can I just generate this particular solution, or this one solution, probably done. To show you where it comes from, I will then regenerate that second equation, which says that x of 1 is indeed equal to my d plus 1, acting on x of 2 minus t squared. It's just as, if that's what x of 2 is, then that's going to give you the following. And in differentiating x of 2, you guys, I just can't see that far. Can you help me with this? Is that a 2c1 e to the 2t? Is that a minus 2c2 e to the negative 2t? And then a 2t minus 3? Plus my x of 2, which I have to rewrite that. This is going to be a c1 e to the 2t plus c2 e to the negative 2t. And then plus t squared minus 3t plus 2. Oh, hold it, you guys. I got a lingering minus t squared term there. I think what that leaves me with is the following. So x of 1 as a function in time t is going to be, well, let me group things together. Here's a term involving c1 e to 2t. Here's another one. I guess it gives me a total of 3 of them. I now have doubly underlined all the terms involving c2 e to the negative 2t, but coefficients added together gives me negative 1 of them. Again, you guys, like in my last example, I'm just trying to maintain consistency with the same coefficients. I think everything left over gives me, oh, look at that, a tad bit of cancellation. Oh, maybe not.
It's a 3t, not 3t squared.
Oh, is it really? Thank you very much. So there is some cancellation. And now combining the t's, I've got a minus t, and the constants is a minus 1. I've got my two solutions. You guys, I'm being kind of clunky. This really isn't the way I solve DEs. It's very math-ish. And maybe in practice, my functions become more extravagant. And so maybe I need to develop another technique for solving system DEs, and I will. I'm talking tomorrow. So can I just show you where I'm going with this inside a few minutes?
Yeah.
This is what x1 and x2 look like. I've got them on the inkboard. They're circled in red. Here. And here. Notice if I so choose to do this, I can rewrite that system of solutions in the following fashion. A vector containing x1 and x2 can be interpreted as nothing more than c1 times, well, another vector, namely 3 and 1 times e to the 2t, plus another vector times a constant c2, and the second vector is going to be nothing more than negative 1 comma positive 1 times e to the negative 2t, plus another column vector consisting of my non-constant terms, which, by the way, are going to be negative t minus 1 and t squared minus 3t plus 2. Well, look what I just did. I rewrote my solutions as a single vector valued solutions. I sometimes say in English, the collection of these two equations, these circled in red, are my scalar valued function solutions, whereas this is my vector valued solutions. Notice it's a linear combination of these two vector valued functions plus another vector value function.
What-
When I say vector value function, I'd be careful with my language. I really can rewrite this one as in the following fashion. That's not a scalar vector. Plus c, did I miss my substitute? Times this vector if I so choose. That choose is not a constant vector, that's a vector value function. Even this one over here, not with all my c's, is already written as a non-scalar value vector.
What chapter is this?
I have no idea.
Is this getting into 7 here?
You know, this is all over the place in 7,
It's all over the place, 7? Okay.
if you don't want me jumping around. So you guys, this is where we're going with this. It's just that in general, to find these two kinds of solutions, it's a bit mathy. You and I might cheat and use more sophisticated tools like eigenvalues and eigenvectors. Oh shoot, unless it's the case that we have a defective matrix. Not enough eigenvectors for the corresponding matrix A. In that case, we'll have to finagle the fact that we're introducing more factors. Can I just tell you where I'm going with this? I'm just going to start throwing in factors of t. Just like we did when we had duplicity with complementary and particular solutions. Can I have you guys take just tiny, tiny steps today? Just using the math of the business. Nothing more.
What's the quiz on tomorrow?
What's the quiz on tomorrow? Jeepers, I haven't thought about it.
Just do a take home.
What was the last quiz on? Was it really?
Yeah.
No, you had to take on variation parameters.
Oh yeah, variation parameters.
So tonight, how about if I write one on Cauchy-Euler? Cauchy-Euler.
Can we get a take one this week as well?
Yeah, that'd be awesome. Cauchy-Euler. Yeah.
Ouchie.
Groucho
Guys,
Euler.
Now be nice to the French. Can you guys, I'm sorry to do this, I'm really tired. Can you remind me of long?
Yeah.
I'm still at 6.3.
You're still at what?
6.3.
Jeez, man, you got lots.
I don't have time all this week.
I'm a little bit behind us.
All right, I'm happy.
I'm pretty close to where we're supposed to be.
Yeah.
Up to 13 off.
These last 2 weeks,
Yeah, but all this stuff is kind of blending together, and it's all just a bunch of math.
It'll blend together much more.
Much more? Awesome.
Finally.
I actually really like this stuff. This is a lot of fun.